Hello, class, and today I just want to go over your week one assignment for those of you that need a little bit of a review on this material. And so I'm going to begin with one of your questions, which was simply interpreting a pie chart. If you notice here, they are telling you that there is a pie chart, and this pie chart as a circle right now looks like just I mean, it's a circle. It's all you see, right? If you were to look at this, you can approximate what the values are based on what we know the dimensions of a circle are. So we need to establish what some of these values actually look like. So this basically is asking you to show the pie chart, shows the percentages of total revenue that a publisher receives from various types of publications, and then answer the questions below. So notice that this says which category accounts for approximately 1/5 of the publisher's total revenue. So in the case that you are possibly having issues with this question, let me bring you back to some basics. So, not those basics. Let me give you other basics. If I'm looking at this, I'm looking at, again, here's my let's see if I can get a nice little circle going here. All right. And so let's assume we have a nice little circle here. And when you look at a circle, I want you to think of this. Obviously, the whole circle is 100%. If I split the circle, let's say this is half of the circle, this is 50%. If I split it again, that's now 4 sets of 25%. And when you look at this, I want you to understand that if I took this 25%, which is just this little section here, and I split it into, let's see, I want to split it into 5 sections. 5% sections, basically. So 1, 2, 3, 4. This will give me 1, 2, 3, 4, 5. Yes, it will give me 5, but that's not lined up. Let me make it a little larger on this side. 2, 3. Okay, so we're going to assume these are all 5%. So it takes 5 of these, obviously, to make the 25% for this. So each of these slices is 5%. So mentally, once you make that decision, right, you're going to go back to your question. And as I'm looking at this, I'm going to assume poetry is my 5%. When you look at the next section, it says approximately what percentage of the total revenue comes from magazines, and paperbacks combined. So they're asking you to estimate. Now, if you look at this carefully, you could tell that magazines is slightly more than 25%. Paperbacks is probably double what poetry is, if you estimate again. So I would say somewhere around what would you estimate this to be? So it's not there. We know magazines is, in my opinion, I would think that that's slightly more. Let me see. As I'm looking at that line, that is slightly changed. So let's go with, if you were looking at this, could you split this into 3 or 4 parts? So let's go with approximately 40%. If magazines is somewhere around, this is slightly more than 25. I would say this is 10% if I were to assume poetry was 5%. So this should be about 10%, and about maybe another 30. So yeah, about 40%. That's what I would estimate. Now, again, this is not an exact science, so chances are you're going to get these questions wrong a couple of times as you are playing with or toying with the estimates. If the revenue from poetry is 5% of the total revenue, approximately 1% of the total revenue comes from nonfiction. I would say 10% if I split that. So maybe paperbacks is not exactly 10%. Maybe paperbacks is more like 15%. So that might change my answer for B. Do you see where I'm going with this? So you're sort of justifying. If you look at the explanation here, this is where they're going with this information. They're splitting the pie into fifths. And so looking at this, notice that part B is approximately 40%, like I estimated. And when it comes to nonfiction, it is about 10%. And so that's what they're doing, is they're basically taking that pie and justifying its values based on that. The second question you had were to compute values from pie charts. So when you look at computing values from pie charts, they're going to give you some numbers to estimate. So now they are actually giving you the percentages. And so in this question, it says the students of a certain college were asked to choose which 6 movie genres was their favorite. The pie chart below shows the distribution of the students' answers. Now, there are 14,000 students in this question at this college. How many of the students chose horror, comedy, or other? Horror is 6%, comedy is 15%, and other is 39%. So what we're going to do is we're going to grab a calculator and we're going to begin with adding our percentages. So 6 plus 15 plus 39, well, that puts us at 60. So 60% is the percentage times 14,000 means that, sorry, I used the whole number. So it's 0.60 times 14,000. And so we get approximately 8,400, which is what we estimate. All right. And so if you are unsure, look at the explanation. It'll help you. In the explanation, you could see that they are basically doing the same thing. They're adding the percentages, 6%, 15%, 39% to get a total of 60%, and then multiplying that times 14,000 to get 8,400. Okay, the next question is talking about interpreting a double bar graph. When interpreting a double bar graph, you need to establish a category. So there is what we call a grid that helps us understand, what the red is represented by males and the stripes are represented by females. So we have advertising, marketing, production, accounting. These are obviously 4 different accounting four different departments. It says estimate the number of males in marketing. Now the number of employees is over here. So this is how many employees on the left side where you see the y-axis. And so if I'm looking at estimating the number of males in marketing males are in the red, and so I'm gonna look at this chart here, and if you look at this chart and you start thinking, well, maybe I can break this up into tens or what have you. Let's go by tens. If you split this into fives, so this is what would you say? This is approximately 190. So we have approximately 190 males in marketing. That's an estimate. So you're just below 200, and I'm coming down about 10. Which department has more females than males? Well, the only department that seems to have a higher stripe bar is production, and that's what they're asking there. So can you read that chart? Estimate the number of employees in accounting. In accounting, it looks like I have, again, if I break this into tens, this is about 140 plus 100, so I would say 240. Okay, and here's your explanation again. So if you're having issues, they noticed that for number one, I did say in 190, but they are estimating anywhere between 175 and 200 as an acceptable answer. For part B, obviously we could see the production, and they are bringing that as a highlight. And 240 is what we estimated for part C. Okay, so you do have a nice explanation there to go by. Now let's talk about the stem and leaf. The stem and leaf is really great because you can actually see the shape of the distribution, whether in this case you could tell it's, I would argue maybe it's approximately normal. Okay, so what was the greatest number of orders overall? So when you look at the number of dinner orders, you have the stems, which are the 3, 4, 5, 6, 7. When we interpret this, this is like 35, this is like 39, 43, 46, 47. So you actually have to read these going back to the stem. So 72, 76, 77, 78. So the greatest number of orders overall in this case would be 78. What was the least number of orders in the 50s? So specific to the 50s. And by the way, this is referred to as an ordered stem and leaf. And the reason why it is ordered is because the leaves are, if you notice, they're in numerical order. So what was the least number of orders in the 50s? You would say 50. On how many nights was the number of orders in the 30s? And in this case, this question, how many nights was the number of orders in the 30s? And it looks like 35, 39. So let's look at the explanation here. Again, the greatest number of orders, obviously, in this case, is 78. The number of dinner orders in this case was actually 50, 56, 57, 57, 57, 58. So they're actually counting out 1, 2, 3, 4, 5, 6. And obviously 50 was the lowest. And when we look at the 30s, the number of orders in the 30s, there's two nights, 35 and 39. Okay, and that's what they're asking in that question. The last one, classification of variables and levels of measurement. So we're going to talk about this for a minute. And so okay, so when we look at data, you have to think of the classifications in terms of quantitative, qualitative. And so I'm going to draw you a little chart. So when we look at data, we have continuous data. This is data we measure, like height, weight, liquids. And then we have the data that we count, which is the discrete data. This is why stats can be confusing, because there's so many splits in a sense. So when we look at data, this is what we're looking at. Now, in terms of the data, you have the continuous measures and the discrete measures. Again, discrete we count, continuous we measure. And in terms of continuous and discrete, we have what we call quantitative, as in quantity. So it would help you to think quantitative quantity. Qualitative data has to deal with quality. So it's a description, categorical data. So quantitative, qualitative, I'm just going to put qualitative. Now, in terms of this, we also have what we call the 4 levels of measurements. So it's nominal, ordinal, interval, ratio. The only 2 values that we actually respect in the sense of you can obtain a mean and a standard deviation are the interval and the ratio. So interval and ratio, you can obtain a mean, you can obtain a median, and obviously you can obtain a mode. In interval, the difference is interval goes between negative numbers with 0 as a possible value and positive, like temperature. So if you think of temperature, it could be negative 30 degrees. It could also be as hot as it is in here in Florida at 90 degrees. Now, ratio starts at 0 and goes on to positive infinity. That's like weighing yourself in the morning. That's weight. Ordinal is when we have values that are placed literally in order. So like your grade level. You start off a freshman, then you can become a sophomore, then a junior, then a senior. And the least used or the least regarded is nominal data. And in nominal data, we're dealing with names. Anything that's a description, usually this relates right back to, in this case, discrete data. Now, ordinal data is weirdo. This one can be continuous and it could be discrete. So keep that in mind. And obviously, interval and ratio are continuous data marks. Let's go back to our questions. Temperature. What did I just say? Temperature is quantitative in nature, and it is interval. A metal won in a race, you have a gold, a silver, a bronze. Now, we have a rank here. This is categorical, and it is ordinal. Because obviously gold is you came in first, silver is usually second, and so on. Price in dollars of a shirt on the clearance rack. Well, in this case, this is quantitative and it is ratio, because obviously the value of the shirt comes into play and starts at 0. Again, you have your explanations here, and so we see that our values, in this case, for temperature, it's quantitative and it is considered interval. For the metal, we can see that it is categorical and ordinal. And lastly, price, we know it's ratio because there's no such thing as a negative price, right? So that's a ratio, it starts at 0, goes up to positive infinity, and therefore quantitative. All right, so this is a brief overview of just week 1. It's for your edification, hopefully, or clarification of anything you may have misunderstood. And I hope this helps.